Hello everyone. In this video, we are going to look at a previous exam paper and we're going to focus on the chapter of electromagnetic radiation. This paper that we have is for the grade 10s. Without any waste of time, let's get right to it. The question that we have, it says, the type of electromagnetic radiation are arranged according to frequency in the table below. So on the table, we have the type of radiations, which is from the radio waves up until gamma rays. And then we have the frequency of the radio waves and the frequencies till the gamma rays. So we can see now the frequency of the radio wave is the lowest frequency since it is 10 to the power of 5 till 10 to the power of 10. And then as you go down, the frequency is increasing up until we have the largest frequency, which is the gamma rays, and it is 10 to the power of 18 to 10 to the power of 21. So with all the analysis, we can now start to answer the questions. The first question that we have, which is 8.1, it says, how are electromagnetic waves generated? So the electromagnetic waves are generated whenever we accelerate a charge. So to answer the question, you're just going to say the electromagnetic wave is generated by accelerating a charge. Or by accelerating charge. So what does this mean? This means now, if we have a charge, we know a charge consists of electric field. So as the charge is accelerating, this means we have electricity. And around the electricity, we have the magnetic field. So as soon as we have electric field and magnetic field, we are going to have what we call electromagnetic waves. So the electromagnetic waves, we get them when the charge is accelerating. As the charge is moving or vibrating, then we're going to have what we call the electromagnetic wave. So now the second question, which is 8.2, it says, what type of electromagnetic radiation has the highest energy? So we know the energy of what? Of a photon is given as the Planck's constant multiplied by the frequency. So this means any radiation that has the highest frequency, it will have the highest energy, since energy is directly proportional to the frequency. As energy increases, the frequency increases. So the higher the frequency, the higher the energy. So the type of electromagnetic radiation that has the highest energy is the one that has the highest frequency. So in this case, that is the gamma rays. So the next question, which is 8.3, it says, explain the answer to question 8.2. We have already explained the answer. The answer is that energy is directly proportional to frequency. This means what? The higher the frequency, and the higher the energy. So you can just explain it like that to say now energy is directly proportional to frequency. Therefore, the higher frequency has the highest energy. So the next question, which is question number 8, it says that a certain type of electromagnetic radiation has a wavelength of 600 times 10 to the power of negative 10 meters. So we are given the wavelength as 600 times 10 to the power of negative 10 meters. And then the next question, which is 8.4.1, it says identify the type of electromagnetic radiation by performing calculations. So how can we get the type of electromagnetic radiation? Remember, we have the frequencies of different types of radiations. So if we can get the frequency of what? Of a radiation that has this wavelength of 600 times 10 to the power of negative 10, we can be able to select a specific radiation that falls within that frequency. So to get the frequency, we know that the equation is what? Is speed is equivalent to frequency multiplied by wavelength. And the speed of light is a constant. So the speed of light, it is always 3 times 10 to the power of 8. So to get the frequency, we're just going to substitute the wavelength, which is given to us as 600 times 10 to the power of negative 10. So we have to divide both sides by 600 times 10 to the power of negative 10. And then we put everything into the calculator to get the frequency. So now if we punch in the calculator to say 3 times 10 to the power of 8, all divided by 600 times 10 to the power of negative 10, we get the answer as 5 times 10 to the power of 5 hertz. So now we are going to look at the range whereby 5 times 10 to the power of 5 hertz will fall within. So now, looking at this table of hours, we can see that it is given as 10 to the power of 5, 10 to the power like that. So now, if we look at this answer here, I think this is supposed to be 15 here. 5 times 10 to the power of 15, yes. So if we look at these frequencies that we have, we're going to look at the one that has 10 to the power of 15. So 10 to the power of 15 is this one here. So now if we have 10 to the power of 15, so do you see now this 10 to the power of 15, it has something at the back. It has 5 times 10 to the power of 15. So this will mean it is going to fall in a range of the ultraviolet light, because the ultraviolet is 10 to the power of 15 to 10 to the power of 16. And this one is in between those two. So therefore, by doing this calculation, we can just conclude to say now the frequency that is 5 to the power of 5 times 10 to the power of 15 is going to be the ultraviolet. So now, the next question, which is 8.4.2, they say, state one application of the type of radiation we have calculated or identified in question 8.4.1. So now, the ultraviolet, it is a type of light that is bigger than the visible light. So it is having some sort of like high energy. It can actually maybe harm us to some extent. So now this type of a light, we use it, for example, if we want to sterilize medical equipment, we can use it. Let's say we want to clean some equipment in the medical field for metals, silvers, and all stuff. So we can use it for sterilizing those medical equipment. The other use is that we can use it for security currencies. Let's say, for example, now we have something that we want to protect. We can protect it by ultraviolet light in a form of lasers. For example, we can make lasers inside the room, and then those lasers are actually what we call the ultraviolet light. So we can make it to be something like security purposes. So we can use this for a security currency. Okay, so I think I can only give those two. And then if you want more applications of different radiations, you can look at this on the internet. Thank you very much.